Good day. Today we're going to be looking at assemblies within the Autodesk Fusion environment. And here you can see in a really basic assembly that we're going to create as a caster. And we'll design it, build it, and then we'll have a second video on how to detail the drawings and how to do an exploded assembly of this particular object. It's pretty simple design drawing environment. I'll make the drawing available as a link in the video, under the video, so you'll be able to grab the PDF file of the drawing. Alright, so let's get started. What we're going to do is we'll first create, as a plan, we'll create the base plate, and then we'll create the arms that hold the wheel. We'll create the wheel and the shaft, all as separate objects. And then in the second video, after we've created and applied joints to each one of these, we'll then create the exploded assembly and the detailed drawings in the second video. So here we go. When we begin this particular object, like we have all the other objects, again, it's always about sketch, constrain, develop. So we sketch out this. We create a sketch first, we constrain the sketch, and then we develop the 3D object. So in this case, we're going to create the sketch on the base, and we'll draw a rectangle, because that's the easiest way to create the object. And at this point, we can then apply the dimensions, and these are 3.0 and 3.0. And so this is the base. Now the base has holes in it, and we could put circles in and extrude it with the circles. So it all depends on if you want to use the hole command or if you want to use just circles for the holes. What's the difference? In some cases, in the case of using the hole command, it then recognizes it as a hole. So the part, when developed, becomes a hole and not just a circle. You can also apply threading to holes that you can't apply just in the simple circle, or it's not as easy. It's an extra process. So I always like creating it using the hole tool, and so this is a unique environment for that. So we'll go ahead and choose Finish Sketch and Extrude. So again, we're going to drag the extrusion up. The extrusion thickness in this case is 0.125, which is 1/8 of an inch. And there we have it. Now the holes are basically 17/32, which are just a 32nd larger than a half inch in the diameter of the hole. So with that being known, I could create a hole, and we know that the placement is a pattern, or from sketch, multiple holes. And so if we chose from sketch multiple holes, we could put a sketch on it with the 4 points and have it fully dimensioned, and it would create all the holes at once. And that's usually a really good idea to do. Now we could copy it and try to do the multi-hole option, which is a rectangular pattern, and we can try that option too. Okay, so what we're going to do is we're going to create a hole, and then we're going to use the rectangular pattern option to pattern it. So the first step is to create the hole, and we're going to place the hole on this surface. When we place that hole on that surface, it will want some reference geometry, but we also need to make sure that it is 17/32 in size. The hole is going to go all the way through the part, and our first reference is from this edge, and that's going to be 0.50, and the second reference is from this bottom edge, and that's also 0.50. So now that we have one hole created at 0.50, we'll pattern it to the other 4 corners. And so using the rectangular pattern, we first have to select it as a feature. Since this is a feature object, we'll select our feature object. The directions we're going to pick include this direction and this direction. we're going to want a quantity of 2 in each direction, and the distance between the two, if you think about it, it's a 3-inch part. We subtracted a 1/2 inch on this side, subtract a 1/2 inch on this side, that leaves 2 inches between each spacing. And so we want, instead of the extent, we could do the spacing between the two or the extent overall. So we're going to do spacing between the two. And so it's 2 inches in one direction, and again, 2 objects, 2.0, because it is a 3-inch square, and we choose OK. And so now we've created all of our holes in one quick sitting. We also have a radius here, and I believe the radius isn't specified on the drawing, but it looks like it could be a 1/4 inch or an 1/8 inch. Since you know that that's a 1/2 inch, it could be as small as an 1/8 inch. So let's go ahead and put a fillet in. And then when we do the fillets, we're going to pick the short segments on all 4 corners at once. And the advantage is, since they're all selected, we can edit it all at once in case we change our mind. So an 1/8 inch fillet, and let's take a look at this. This looks really good at an 1/8 inch, so I think that is the right size at an 1/8 inch. And so now we've got our plate completed overall. And so with the plate completed, we're then able to move on to the next step, which is creating the arm that allows us to create the holder for the wheel. So this arm is what we're going to create next. And so I had to add an additional dimension because it was missing here in the original drawing at 1.75, and then the shaft and the roller mounting is a 1/4 inch shaft, and it's a pressed fit, so it's going to be a 1/4 inch shaft and a 1/4 inch actual hole through, so it is pressed into place. All right, so with that being known, what we're going to do is work on the shape. So we have to, oh, by the way, this is now an object. It's called a body. If we want to assemble multiple pieces onto this body, or if we want to create multiple objects for an assembly, we have to change the body to a component. And this gets a little tricky because this particular plate would be created. The verticals would be welded in place, more than likely. They wouldn't be part of the plate itself. They would actually be welded in place, so they'd be a separate object. So with that being known, I'm going to hit the arrow next to bodies, and under body 1, I'm going to slow click and call this top plate. And so naming objects is really important. I'll then notice that it's considered a body, and I'm going to create a component from the body. So this now is a component. Notice that it's a block now instead of a cylinder. I know it's a small difference, but that's a huge difference when you're doing assemblies with joints. We're now going to create a new body, and that new body is going to be based on the edge of our part. So now we're looking at the edge of the part, and with this particular drawing, we have to lay out some construction lines, and the construction lines help us position where we're going to create the tangent arcs in the object. So initially I'm going to draw a line, and it's going to be in the center here, and we can find the midpoint, and I'm just going to continue to draw up, left mouse click straight down, and right mouse click and choose OK. So now that we've created a line, I'm going to highlight it by left mouse clicking. We'll right mouse click to get to the options, and we're going to call this a construction line. That is the center of the object. Now let's say you're not too sure if you got the exact center of the positioning. Well, how can you put a measurement on? Well, if I pick the dimension option, I can dimension the line, but I can't dimension anything related vertically to the last object. That's because we put these nice fillets on the corner, and there's no corners here now. So as we know, we could use a tool called projection. We can project to our current sketch. So if we project, and we can project the whole filleted area, but we actually only need to project this edge. So if we project just this edge, and there's a really light blue line that popped up there, I can now dimension from the construction line to the other line, and we can prove that it is 1.5 inches is our total distance. We also need to offset this construction line. So if we use the offset tool, this works really smoothly. So we pick the object, we then drag towards the direction that we need, and this one's going to be in a negative direction. So it's negative 0.75. Now granted, it comes up as a solid line. So we pick it, right mouse click, and make it a construction line. We'll do the same thing again with the offset, selecting the original, and we'll offset it to the opposite side, this time 0.875. Enter. Right mouse click and make it a construction line. Alright, so we also have an additional construction line at 1 inch from the original. So we can go ahead and offset that. And highlight and make that a construction line. And then we'll draw one horizontal line. And I'm just going to draw it right along here. And that horizontal line is also going to be a construction line. However, notice that because it's not dimensioned, it's a different color. All the other lines are color changed to black. This one is still a brownish color, which indicates that it is not constrained. So we need to constrain it from the bottom of the plate to the line. That dimension is going to be 0.125. And that's because we're going to be creating 1/4 inch circles as placeholders for our arcs, as tangency locations. So we're going to create a circle at this location, this intersection, and it's going to be a 1/4 inch total, which, by the way, here to here is a 1/8 inch, so we double it, it's a 1/4. And again, we can pick the circle, make it a construction line, and we'll do the same thing at the 0.875 location. So the nice thing is I can move these dimensions out of the way, so they're kind of not involved. And so we'll pick the circle and change it over to a construction line. So now we've got the circles and we're all set. So we've got our basic construction mode, but we have one additional circle. If we take a look, notice that we've got the 1 inch, we've got the 0.875, we've got the 0.75, but we don't have this 1.75 from the bottom of the plate to find that horizontal location down here. So we need to do one more line at the bottom, 1.75. So I'll create a short segment. I don't need a very long one. Again, making it a construction line. We'll dimension it from the bottom of the object to the construction line, and that's going to be 1.75. Ooh, that's really, really tight. It does make it, but I could also grab and just drag this line. I can just choose OK. I can take and grab and drag this line a little bit farther down. Just kind of grab the line and drag it down just a bit. And that just gives me a little bit more confidence of where the circle needs to be located. And so with that, since we're zoomed in here, that circle is 0.375 as a radius. So when we create the circle and dimension it, it's going to have a diameter of 0.75, which is 0.375 times 2. So that's the circle that it's going to be tangent to. Now we've got to create an arc that's tangent to this large circle and tangent to the small circle. So what I'm going to do is something that's kind of unique. Notice that we've got the constraint tools up here, and we've got a tangent geometric constraint. And a lot of people would just go and say, hey, why don't we just create an arc? And they've got a tangent arc, and we can just pick 2 points and create the arc. But we don't know the exact tangency points. That's the key. So what we can do is create a circle, and we can do a tangent 2-point circle or a tangent 3-point circle. And so if we do a tangent 2-point circle, I can pick that. See, it's only going to work to lines though. Well, that's not going to help. So what I really need to do is just create a circle and make it large enough, because we're going to go ahead and edit this anyway. So I'm going to make it a really big circle. So I created a really gigantic circle, and I'm going to say I want the circle to be tangent from this circle to the new circle that I just created. And then I want it to be tangent from the construction line circle to the big circle. And notice what it did is it connected it and made them both tangent. So I just made a tangent circle. Well, what's nice about this is that we know that the radius on this circle is 3 inches, which means the diameter is double that. So now I can put a dimension on the circle of 6 inches. And that positions the circle appropriately. Now I can trim it. So I can use the trim tool, trim the circle. Well, what's nice is that the circle will automatically trim here to the tangency point. Up here, it trims to this top line, but I got to still nibble at it. And I nibble down to the tangency point. Well, I need to do the same thing on this circle, so the process works exactly the same. So I create a circle. I know that the circle is going to have to be fairly large. And then I'll use the tangent tool and say I want this arc and that circle to touch. And I want this arc and that circle to touch, and then I'll give it a radius, or in this case a diameter, and this one happens to be a 2-inch diameter circle, or a 4.0. So what happened is it flipped it. So now what do we do? Well, the first thing that I would do is undo, because we had it in the right location prior to typing it in. The second thing I would do is trim it up a bit before putting in the dimension. So right now it's 4.08, and I can delete that dimension, and I can trim the circle up. Now, if I do this and I put in a dimension, it's going to be a radius dimension, and it's going to be 2 inches. And it doesn't like, did I put it on the wrong side? Nope, I got it on the right side. So it still doesn't like the 2 tangency positions. And so, of course, when you do the demo, it never works. So let's go ahead and trim this up even further. And 2.4 should be 2.0. And it's because of the flexible center point. Oh, I bet I put the center point on this line, so it tries to keep the center point on the line. Let me undo this. That was my error in how I created the circle. So let's try this again. We're going to draw the circle. We're going to create roughly, and we can create a 4-inch circle actually. So we could create a circle that is 4.0, because we know what the radius is. So with this circle, I can grab and move this data point, and so I can kind of get it close. And with it getting close, I can then use the tangent tool and say I want to make this circle tangent to this circle. And then I want to make this circle tangent to that circle. And everybody's happy now. So again, it does matter what you pick and how you accomplish it. And if we trim this, this will trim up. We got to nibble away at it. Like I said, it's just a nibbling process. And that should be all set. Perfect. And we can even nibble away at this arc because we no longer need the full circle. We just needed the arc. All right, so we're not fully complete yet. This particular design has a straight line coming up from the tangency point. That line goes across to the other side. So we're going to draw a straight line up, and then we'll draw a line straight across. And what that does is that creates a solid object here. Okay, creates the solid object. Now I also indicated that it is a 1/4 inch diameter hole, and we could create just a circle and dimension it at a 1/4 inch. And right now it says that it's okay, that it is exactly a 1/4 inch. And we can finish the sketch because we're now finished with the sketch, and we can extrude it. So if we extrude the sketch, selecting it, dragging it, and making it an 1/8 inch thick, we now have our second part. So again, this is a body, it's not a component. So to move this in the right location, we need to change this over, and all it is right mouse clicking on it, and we're going to create a component from the body. So component number 2 is the arm. So with this arm, I'm going to need to make a copy of it because I need 2 arms, one on each side of the wheel. So as we right mouse click, I can choose copy, and then I can choose paste, and then it's going to ask me where do you want it, and I'm just going to want it off to the side here and choose OK. So far so good. This one is still fully movable also. They both move. Now we can create the wheel and make that another component, and we can create the shaft and make that a component. I'm just going to go through the joint process of the arms. The other joint process of the wheel and the shaft we could do on our next video. So maybe this may be a 3-part set as opposed to a 2-part set. So constraining this. When we assemble now, we use a tool called joints, and joints can only be applied to components, not to bodies. So when we choose the assemble, I'm going to go ahead and capture the position because I moved some objects. What we need to do is decide on what are the knowns and unknowns. And the known on this particular object is this top face. So I know that this top face is going to be connected to the bottom of the top plate. But where? If you notice when I highlight it, I've got a series of data points all the way around that top face, in the middle on all the ends, in the middle on the ends. Well, I'm going to pick the middle, and I'll explain why here as we go forward. But I'm going to pick this point as my connection point. Now it turns it really light gray and it's hard to see because I need to pick a new data point. Well, that data point's going to be on the bottom of the plate. And again, I highlight the bottom of the plate, and what do we get? We have data points all over the place on the bottom. But what's the one that connects to this one that we selected is the middle. Well, we know that the middle is exactly 1.50 from the edge. All right, so now we've made a rigid connection to that location, but it's not done yet. What's different between this joint and the constraint tools is that not only can I apply the mate type constraint, I can also apply a second constraint at the same time that moves it into the correct position from the point that I selected. So I picked the middle point. We know that the width of the wheel is 3/4 of an inch thick. So I'm going to allow a little bit of spacing between the two vertical arms. So we're going to put 1 inch between those spaces, or 1 inch between those objects. So if I do that for the wheel, then what will happen is I need to move this particular object out. Let's see here. 1 inch minus the quarter. We'll move this out 1 inch. Let's see what happens here. So we'll drag this. And if we move it out 1 full inch, that's not going to work. So we're going to have to move it out a 1/2 inch. So if we go a 1/2 inch this direction, 1/2 inch the other direction, that gives us 1 inch in the middle, which is what we're shooting for. So 1.0 is, 0.50 is the correct location. So from the center point, we're going to move it out a 1/2 inch. We'll choose OK. Well, we're not done yet because we still have one more arm to constrain and assemble. And we're going to pick again the top surface in the middle as the joint. And we know what happens is it connects to that location in the middle. In relationship to this, we're going to drag this a negative 1/2 inch away, which is what I did, negative 0.50, and we hit the enter key, and now the two arms are located in relationship to the top plate. Well, the other objects, the wheel and the shaft, are pretty easy to create. It's just a circle extruded 3/4 of an inch, that's 2.5 inches in diameter, and we know that the shaft has got to more or less connect from one end here to one end here. We know that there's an inch in between, and so if we measure this distance from the outside surface to the outside surface, we know that it's 1.125. That gives us our shaft length. Have a great day, and we'll be with you soon. Bye now.